So today we'll try to understand what is empirical formula of a compound, and what do you mean by molecular formula, how we can derive the molecular formula of a compound from empirical formula when the molar mass of the compound is given. So what is empirical? Empirical, the literal meaning of the term empirical means something that we know through our experience or through observation. Like there is not we are knowing it not through some theory or some kind of law or some kind of logic. We are trying to understand it through our observation by experiments and through our experience. That's what we call empirical formula. So we are going to calculate the empirical formula of a compound. And what is empirical formula? Empirical formula of a compound, it means it gives the simplest ratio of the various atoms that are present in the compound, and that too in whole numbers, not in fractions. The simplest ratio of the atoms, different kind of atoms present in the compound in whole numbers is known as empirical formula. And what is molecular formula? Molecular formula is the exact, not simplest. It should be the exact number of atoms of different elements that are present in a compound. So there's a relation between empirical formula and molecular formula. When you multiply the empirical formula by some number, it will become a molecular formula. The empirical formula is in simple form, and this contains the exact number of atoms that are present in the one molecular compound. And molecular formula is generally related. If we are not saying molecular formula, it will be related to covalent compounds. So it will be of covalent compounds. So for example, in the textbook, they have given that there's a compound which contains hydrogen, carbon, and chlorine, three elements, and their percentage is given. It contains 4.07 of the compound is hydrogen, 24.27% is carbon, and 71.65% is chlorine. So this is called mass percent, and it's calculated by like percentage of the mass of the substance in that compound. So what we'll do is that we will assume that the given compound is of 100 gram. So in 100 gram of the compound, there will be 4.07 gram of hydrogen, 24.27 gram of carbon, and 71.67 gram of chlorine, right? Next, what we will do then we are if we are knowing mass of some element, then we can calculate that mass contains how many moles are there, right? Because we know that one mole of a substance, we know one mole of a substance, its molar mass is nothing but is numerically equal to the atomic mass or molecular mass of the substance in grams, right? So molecular mass hydrogen is how much? 1.008 gram. Molecular mass of carbon is 12.01 gram per mole. One mole of carbon will weigh this much, and one mole of chlorine weighs 35.5 gram. This is constant. Now 4 grams, one mole is 1 gram for hydrogen, right? One mole of hydrogen weighs 1 gram. 1.008. Let's assume it 1. So 4.0 gram for the given condition. How many moles will be it? So we will divide 4.07 by 1.008. So this many grams. So approximately 4 divided by 1 is 4. So it is around 4 mole. 1 gram of hydrogen means 1 mole. So 4 gram will be obviously 4 moles, right? So what we are doing here is that whenever you wanted to calculate the number of mole of a substance, what you do is you divide the given mass of the substance by the molar mass, and you will get the number of moles. That's what it means. But you try to understand it instead of just trying to memorize the formula. In many textbooks it's given like number of moles can be calculated by you divide the given mass by molar mass. Why you are dividing? You just apply simple logics. See 1 mole of hydrogen means this much. So this many gram means how many mole? You divide it, right? 1 mole means this much gram. If you're given this many gram, then how many moles are there? Surely you will divide. Obviously you will divide. Similarly, you find the number of moles of carbon in the compound, in 100 gram compound. It will be how much? 24 divided by 12 is approximately 2. I'm making it more simple. I'm not doing the exact calculation. Similarly, the number of molecules of chlorine is 71 divided by 35.5. So it also comes around to 2. So what we are finding that in 100 gram of the compound, there will be 4 mole of hydrogen atom, 2 moles of carbon atom, and 2 moles of chlorine atom. The mole, not only it means the mass. By knowing the mole, we are knowing the mass. We are also knowing how many entities are there. How many entities will be there? Avogadro number of entities, and which is 6.022 into 10 to the power 23 atoms. So 4 mole of hydrogen means 4 multiplied by Avogadro number of atoms, or 4 multiplied by 6.022 into 10 to the power 23 atoms of hydrogen. Similarly, 2 moles of carbon means 2 multiplied by 6.022 into 10 to the power 23 atoms of carbon. And 2 moles of similarly to 2 moles of chlorine atoms means 2 multiplied by 6.022 into 10 to the power 23 atoms of chlorine. So now we are getting what we have got is we have calculated in 100 gram of the compound this much mole of hydrogen atom, this much mole of carbon, and this many mole of chlorine are there. We have calculated the number of atoms that are present in number of atoms of different elements that are present in the compound. So we can calculate the ratio of it. What is the simplest ratio? Simplest ratio will be 4:2:2, 4:2, and we divide it. Since we want the simplest ratio, what we'll do, we'll divide it by 2, because the smallest number we find is 2. So 2 divided by 2 becomes 1, 2 divided by 2 becomes 1, and 4 divided by 2 becomes 2. So simplest ratio of the ways there are atoms present in the compound, that 100 gram of compound, is 2:1:1. Even if it will be 1000 gram, it will still be 2:1:1. Think of it, right? Even if it's 1000 kg or 2 lakh kg of the compound, it will contain this compound will always contain the ratio of the hydrogen, carbon, and chlorine in that compound will be always 2:1:1. The number, right? The number. It's not the weight, it's the number of the hydrogen atom, the number of carbon atom, the number of chlorine atom. Because moles means number, right? So this will be the simplest ratio of the atoms present in the compound, and this is the empirical formula. How will I write it? I'm just writing EF means empirical formula. I'm writing the short form. We generally write the carbon first. Whenever we write this is a carbon compound. So C, then the C1, H2, and Cl1. We do not write 1 in the formula. It is just it's a convention. There's no need to write 1. So it is C1, H2, Cl1. You do not write 1. So CH2Cl is the empirical formula of the compound. Now what about molecular formula? How will you derive the molecular formula? Molecular formula, how will you obtain the molecular formula? We will multiply the empirical formula by some number. Let the number be n, small n. And how will you calculate the sum number? In other words, the molecular formula will be multiple of the empirical formula. So when the molecular formula is the simplest form of empirical formula only. In other words, if you multiply the empirical formula with some specific number, a whole number, it will become the molecular formula. The exact number of atoms of different elements present in that compound. And how will you calculate that number, the n multiplying by which the empirical formula will become the molecular formula? So n is nothing but the ratio of the molar mass. Molar mass by empirical formula mass. Molar mass how much? 98.9, and empirical formula mass is, you calculate from here, CH2Cl. You know the weight mass of carbon is 12, mass of hydrogen is 1.008, mass of chlorine is 35.5. So you calculate the empirical formula mass, it will become 49.48. So 98 divided by 49 is almost 2, or 100 divided by 50 is almost 2. Approximately 2, so we got n is equal to 2. Hence, the empirical formula, if you multiply by 2, it will become C2H4 and Cl2. C2H4Cl2 is the molecular formula of the given unknown compound. Now it is known. It contains carbon, hydrogen, and chlorine, and exact the number of atoms present in one molecule of the compound is 1 molecule of the compound contains 2 atoms of carbon, 4 atoms of hydrogen, and 2 atoms of chlorine. And the simplest ratio is CH2Cl, and this is empirical form.